Alright, welcome to tonight's video on symmetry, asymptotes, and behavior and limits. So we continue our graphing discussion talking about symmetry. And there's three types of symmetry that we'll talk about. The first one is with respect to the y-axis. So if you look at a function with its coordinates, it's symmetric to the y-axis when basically the y-coordinate is the same, but the x-coordinate is the opposite. For example, if you look at a parabola, y equals x squared, that is going to be symmetric to the y-axis because notice if you put 1 into the function, you get 1, and if you put negative 1 in, you get positive 1 as well. So notice it's symmetric, it's a bad drawing, to the y-axis. The y-axis, in this case, acts as a mirror. Another example here, if I drew there, and then notice, let's say I had something like this, and then I had something like that. So notice the y-axis is a mirror for the graph. That is symmetric to the y-axis. Symmetric with respect to the x-axis is when the x-axis acts as a mirror. So notice if you look at the coordinates, you'll have x, y, and then you'll have x negative y. So something that looks like this, a sideways parabola, would be symmetric with respect to the x-axis. Notice these are not functions if they're symmetric to the x-axis, because remember, for every y you can only have, for every x you can only have one y, and this is saying that x has two y's, the positive y and the negative y. So something else that would be symmetric to the x-axis would look something similar to this. Something like that, where the x-axis acts like a mirror. Symmetric with respect to the origin is where basically coordinate-wise you have the opposite of both the x and the y. Notice something like this here, where you have -4, -2, and then you have +4 and +2. Like that. That is symmetric to the origin. Something else that would be symmetric to the origin would be something like that. Symmetric to the origin, because notice the origin acts as a mirror. It's basically symmetric diagonally. You have the opposite x and opposite y in both cases. Like if this was -5 and 4, this would be 5 and -4. All right, the next thing we're going to talk about are asymptotes. There are three types of asymptotes that we're going to look at. The first one is a vertical asymptote. Vertical asymptotes are x equals a number. They never can be crossed. Now, whenever we have vertical asymptotes is usually when we have fractions with a variable in the denominator. So for example, 2 over x minus 5. Well, we know that x cannot equal 5, so therefore the graph will have a vertical asymptote at x equals 5. Horizontal asymptotes are different. They are end asymptotes. You will get y equals a number, and they can be crossed in the middle. They just can't be crossed at the end. They just can't be crossed at the end. Oblique or curved asymptotes are diagonal lines or curved, like a parabola. Can be a curved asymptote. The next concept we'll talk about are limits. Now there are a couple types of limits. First, adjacent to vertical asymptotes. You can take the limit as x goes to a number, whatever the vertical asymptote is, from the right, that's the plus, and you'll say what that equals. That's the right-hand side limit. And the limit as x approaches the vertical asymptote, whatever it is, from the left, that's minus, what that equals. So that's the left-hand side limit. Then there's end behavior limits. The limits as x approaches negative infinity, because negative infinity, remember, is to the left. So that's basically all the way to the left. And then the limit as x approaches infinity to the right, and that's all the way to the right. Okay, so let's do some example of limits. First of all, we're going to find the limit as x approaches this vertical asymptote at 7 from the left. So the left is over here. And if we look as it approaches 7, notice what y is doing. Y is going up and up forever. So as x approaches 7 from the left-hand side, it's going up forever. So that means it's going towards positive infinity. Because remember, on the y-axis, positive infinity is here, negative infinity is there. As it approaches from the right, notice it's going down. So as it's approaching 7 from the right, it's going towards negative infinity. So that's the limit as it approaches an asymptote. As it approaches the end behavior, like negative infinity, so x, negative infinity is out here, and positive infinity is out there. So as x approaches negative infinity, meaning as it goes further to the left, notice it's going down. So it's going down, so it's going to go towards negative infinity. Notice here to the right, it's approaching this 0, but it's not really touching 0. It's kind of leveling off at 0 here. So as x goes more and more to the right, it's going towards 0. So here it asks us to use the appropriate notation to find the limit of f of x shown as x approaches 0. So we're going to do the limit of the function, so f of x, and then we say as x approaches, so that's how you write that, 0. So x approaches 0. Well, notice as it approaches 0, notice what is the y value? The y value here is negative 5. From the left to the right, basically it's asking when x is 0, what is y? And in this case, it approaches negative 5. So same thing here, limit of f of x as x approaches negative 7. Well, negative 7 is over here, and here's the y value. The y value is 0. So as it approaches negative 7, it is going to be 0. That is the limit of x. So remember, when you're finding the limit, you're finding what it's doing in respect to y, the y value. All right, so let's look at this graph here. So we're basically, when you do your homework, this is what it's going to look like. Now we're adding on. Does this represent a function? The answer to the question is yes, it is a function, because if you did the vertical line test in any spot here, it would be a function. State the domain and range. Well, the domain, if you notice, you start from left to right. So it's going to go to the asymptote at negative 2. Then after negative 2, it goes until 4. And then at 4, it goes on forever. So that is your domain. Your range, now remember, range, you're going from bottom to top. So you have to look at it vertical lines. Well, these arrows mean it goes down forever. So it goes from negative infinity. It does have a top here, but notice this line keeps going. And then notice this horizontal asymptote is not crossed here at the end. So basically it goes from negative infinity to 3. And then from 3, it's going to go up forever and ever. So that is the range. Where is it continuous? Well, if you notice, it's continuous from negative infinity to 3, from 3 to 4, or sorry, not 3, negative 2. Because remember, we're talking about x, not y, to 4, and from 4 to infinity. That's where it's continuous. The discontinuities, well, there's an infinite discontinuity at x equals negative 2 and x equals positive 4. That's where the two vertical asymptotes are. The horizontal asymptotes are not discontinuity, because remember, we're only talking about x when we talk about discontinuity. Where is it increasing, decreasing, or constant? Well, it is not constant. Notice it increases from negative infinity to negative 2, and then from negative 2 to 0, and then from 0 to 4 it decreases, and then from 4 to infinity it increases. Then it says state any local or absolute extrema. So here you have, notice you have a local max, because that's the top of the parabola, at, sorry, local maximum of 0 at 0. Now, as far as the graph being bounded, it is not bounded above because of the arrow going up. It's also not bounded below. So therefore, the entire graph is not bounded. So now we get to the asymptotes. Well, there's a vertical asymptote. There's two of them at x equals -2 and x equals 4. Those are your two vertical asymptotes. There's a horizontal asymptote at y equals 3. That's what this is going here. Now the limits. Remember, we find limits as they approach each vertical asymptote and the end behavior. So the limits, first for the vertical asymptote, as x approaches -2, and we're going to go from the right. So from the right, as it approaches -2, it goes down. So it's going to go to -infinity. So now the limit as x approaches -2 from the left, we come in from the left, it goes up, so it's going to be +infinity. Then for the next vertical asymptote, the limit as x approaches 4 from the right. So from the right, we come in, it goes down, so it's -infinity. And the limit as x approaches 4 from the left, we'll notice from the left, it also goes down, so it's also -infinity. Then the end behavior limits. So the limit as x approaches -infinity, meaning as it goes this way. So as it goes this way, notice it's going towards +3, but you have that horizontal asymptote, which means it never touches 3 at the end. So as it approaches -infinity, it goes to 3, and the limit as x approaches +infinity, it also goes towards 3. All right, so we've answered all the questions there, and hopefully this video helps and you have a good evening, and I will see you in next class. Have a good